All right, welcome everybody. Welcome to the CXO series. Today we're talking about the asset health monitoring. And with us, we have the CTO of Tronics Microsystems, a TDK company, Dr. Antoine Filipe. Welcome.
Yeah, thank you very much for this talk.
Sure. Now, those of you in the audience, you may be familiar with TDK. Certainly, it had been the highlight of our entertainment for many, many years with the cassette tapes. But this particular group within the TDK is been helping in many industries like aerospace and energy. And I'd like to ask Antoine, for the last 20 years, Tronics has been the company behind the sensors in aerospace and energy industries where literally there is not much room for error. Now we're going after machine health monitoring in factories. What's driving that decision?
Yeah, so that's a good question. So indeed, Tronics has been active on MEMS accelerometer for aerospace and energy for 2 decades. So we have been selling several millions of sensors and helping several hundreds of customers on these applications. So selling accelerometer and gyrometer. Accelerometer, so we do measure acceleration. And so vibration is a natural extension of acceleration going to larger bandwidths. So for us, this decision was just, let's say, a natural extension of our product portfolio. So a technical push toward new application, to have also facing new exciting challenges. So that was the motivation. Also, we are part of TDK Group. So we joined the TDK family 10 years ago. And also TDK is pushing us to develop new markets. And as you are aware, so there is a long-term growth regarding industrial IoT. So this is giving a good momentum for new products and new suppliers. And that's why we are here today.
Thank you for those insights, and we'll double click a little bit on the maps shortly. But you're launching the Vivo as an exhibit premiere during the Hanover Messe this coming April. Now, if a plant director stops at your booth and says, "We already have monitoring," what do you tell them? What do you tell them to convince them to look at your solution?
Yeah, so indeed, if you have already monitoring in your plant, so probably you are already acquiring data from pressure, temperature sensors, actuators, probably using a standard industrial field bus like Modbus. Now with our Vivo, so our vibration sensor, you will be able to collect also pre-processed vibration measurements using the same field bus. And so this is adding an additional accurate and relevant parameter to monitor continuously your most critical equipment. So that's an additional parameter which is key in order to maintain your facility.
Got it. So just want to understand a little bit the technology, right? Your sensor is built, as you referenced earlier, on MEMS accelerated technology. So in simple terms, would you say the differentiator is the fact that you're offering more accurate? How is that different than what it's being used in as you referenced today, maybe using Modbus or other field type of protocols? How is that different, and why should a business leader care today?
Yeah, so that's yes. So the standard for vibration sensing has been piezoelectric technology for maybe more than 50 years. So it's an analog technology, and it's a good technology providing accurate data, but it's analog output. So rather complex to transfer to digital world. MEMS technology is more recent. So it has been developed at the end of the 90s. So it's well established, but it's only 30 years ago. So for industry, it's not so long. And so MEMS is basically reusing technology developed for semiconductor industry in order to process micro-mechanical structure. So we reuse technologies coming from the semiconductor. So it means intrinsically it will be smaller, it will be low power, and it will be digital. So that's a key differentiator compared to standard analog piezoelectric. And if you look at the other industries, what we can say in the consumer field, so MEMS has been completely replacing piezo acceleration sensors that were used in the end of the 90s, beginning of this century, and with the smartphone, MEMS completely replaced piezo. In the aerospace domain that we are serving, the replacement started 15 years ago, and now it's really well on its way, and that's the long-term trend we are growing. And so, for sure, as a business leader, you can expect the same to happen in factories. So at some time, it will move from analog piezo to digital MEMS. So it will happen for sure with Tronics, we hope so. But there is no doubt. So the question is, what will be the speed of adoption? So we know, as we have been serving the aerospace industry, that it can be rather long because, the qualification and so on is taking time, but at the end it will happen. So let's see the speed of adoption. Let's follow that in the coming years.
Got it. So you've talked a little bit about how it's a more modern technology, and a traditional sensor perhaps gives you the raw data that someone still has to interpret. Maybe talk about how your sensor, the Vibo, actually tells you what's wrong with the machine, perhaps? What does the different look in practice for someone that's supporting a plant or running a plant?
Yeah, so most digital vibration sensors currently are coming with wireless communication, which is usual, let's say, one way to address the sensor.
Mm-hmm.
But this is bringing also some key changes for plants, especially because it's sensitive to electromagnetic fields. And as you know, in factories with large equipment, with very large power, this is generating extremely large electromagnetic field. And usually, plant managers, they know that in some areas of their plants, they cannot rely on Wi-Fi, neither 5G, because it's too sensitive to the electromagnetic field. So that's the first limitation. The second one, if really you think wireless, so as a smartphone, so no wire, then you need to rely on a battery. And battery, as you may know, also has some limitation related to temperature. So a battery cannot be used above 85 degrees Celsius. So and then it can burn, it can explode. So that's dangerous. So some large equipment, very powerful, they can go up above 100 degrees Celsius, above boiling temperature. So if you are using a wireless digital vibration sensor, then there is part of the factory you cannot use it, and there are some equipments you cannot use it. So at the end, there is a limited window of opportunity for the vibration sensor. So on our side, what was also a bit surprised when we tackled this market is that what we see a good momentum for wired digital sensors. So using standard industrial field bus that will be connected to a gateway that is then wireless connected to the IoT world, so to the cloud. Mm-hmm. So it's a two-step. So it's indeed, at the end, it's like a wireless sensor, but it's wired to the IoT wireless gateway. And then this gateway doesn't need to be on the equipment. It can be 10 meters away from the equipment. And so it can stay, let's say, in a rather standard temperature location with limited electromagnetic perturbation. And so this is providing the best of the both worlds. So you have the capability to do measurements everywhere, and at the same time to have a wireless communication to the cloud, so enabling the data analysis to be performed on the cloud directly. So that's that's the feedback also we got from the market, which is indeed a little more complex than what we could expect from a smartphone. So assuming we put a smartphone on the equipment, this is not directly working. And it's rather usual for industry, the specific segment, and we need to adapt the technologies to this application case.
Yeah, thank you for the insights and the context into replacing or the wireless sensors and the analogy with strapping a smartphone to heavy equipment. I'd like to maybe switch the focus a little bit on the Hanover, and the theme this year is Think Tank Forward, and supply chain resilience is everywhere in the conversation with all the issues around that. Your sensor is built entirely in France, start to finish, with aerospace, great quality standard. Is where it's made now part of the buying decision for customers?
So, yeah, so that's a good question. So it has been the case for aerospace customers for a very long time, at least for the last 30 years. So it's a really critical decision making point for buyers in Europe. Is it made in Europe? So, and in France. So why? Because these customers are sensitive to export control regulations, especially from the US in the past. So with the ITAR regulation. So this was indeed a key element, and this is still a key element for aerospace. For industrial customers, in the past, to be frank, usually they do not care at all. So if they have good quality at good price, that's what they are looking for. It could come in the past from the US, China, Europe, Brazil, Japan, Taiwan. It was okay for them. But now, with all the changes in US and also Chinese tariff and custom regulations, as well as new export control rules. So we can mention, for example, the latest China rare earth export restriction. Industrial buyers start to think about it, and maybe they have to take care a little bit more on where are the products coming from. So I think it's changing now. So it's difficult to predict the future. So let's see. It could change. That's correct. It did change in the aerospace industry for rather a long time ago. So will it happen in the industry? Maybe. So let's discuss during the Hanover Mesa. Maybe get some additional insights on this subject. Yeah.
And before I get to the final question on the Hanover Mesa, maybe just a quick real world proof, right? Can you walk us or walk the audience through a specific use case, a type of machine or industry where your sensor has already been tested, and what do the results look like compared to the monitoring they had before in place, whether it's wireless or others?
So indeed, we did a comparison on two use cases. So one of them is for pumps, looking at defective bearings on vacuum pumps. So that's the most challenging, because we need to look at very high frequency. So that's really that was a good test for our product. So, and thanks to our 20 kilohertz bandwidth and capability to do edge processing, at the end we delivered exactly the same output as let's say a standard analog piezo accelerometer, but directly with a pre-processed digital data. So we were able to detect the defective bearing with standard data processing, so using envelope detection. and but without any additional data conditioner that is needed for analog piezo sensor. So that was that's a use case which is proven now. And the second one is on industrial gearboxes, and we are able to detect inner and outer rings defaults on gear train. So similar to, let's say, standard piezoelectric vibration sensor. And that's really a key benefit if you compare, let's say, with standard MEMS sensor that have not been customized for industrial application. So some companies are reusing MEMS developed for consumer application, expecting that they will match the expectation from industrial customers. But most of the times, this is not working because consumer and industry is not the same, and the expectations in terms of accuracy, stability, signal to noise ratio are not the same. So that's key proven use cases of our vibration sensor.
Thank you. So the pumps and the gearboxes sounds like the two good examples there where you have data. And on that note, maybe for the decision makers that plan to be at Hanover in April, what's the one shift they should pay attention to, and what will they experience in Hall 27 stand J73, which is where the Tronics Group is located?
Yeah, so we'll be part of the predictive maintenance and machine learning pavilion, so located in Hall 27. So here you will be able to meet a dozen of companies that are exhibiting solutions for predictive maintenance. So we'll be part of this exciting pavilion. That's really interesting. And so on our booth, so J73, we'll showcase real equipment with our Vibo sensor and with the analog piezoelectric sensor. So you will be able to challenge our sensor with, let's say, the historical standard. And you will be able to discuss with our field application engineers, so regarding your latest machine health problematics.
Antoine, thank you so much for your insights. And if you're in the audience and have questions about the sensors, about this predictive maintenance, feel free to leverage the hashtag you see on the screen. We will be on the ground. We will be interviewing the field application engineer and the team at Tronics right from Hall 27 at Hanover Mesa. Stay tuned for more information about this sensor and other technology from Tronics.